Hello everyone, welcome to G-Technology. We all know camera resolution. Better resolution, better images. Likewise, satellite to have resolution in a different way. Similar to camera, but different types of resolution. Let's have a look. First, what is resolution? The word resolution, resolution, itself telling clarity or details of something. It refers to the ability of the sensor to distinguish between closely spaced object or features on the Earth's surface. It determines the level of detail that can be captured in the imagery. Next, types. Basically, a resolution is categorized into 4 types: spatial, spectral, temporal, and radiometric. Spatial resolution. The size of the smallest object that can be detected in an image, usually expressed in meters, indicating the ground area represented by each pixel in the image. Consider left side as the ground area. Here I categorize with 4 different colors such as vegetation, buildup, water and others. And these are captured and represented as a pixel in the image as I shown in the right side. Each square you are looking in the screen is considered as the pixel. As I mentioned, 60 into 60 per pixel. This too has types. Categorized under the detailing like zooming effect in our mobile. Much or how long we can see the details means features. On the basis it is categorized into high, medium and low. For high resolution, the less than 1 meter to 4 meter per pixel, and for medium spatial resolution it's 5 to 30 meters per pixel, and for low spatial resolution greater than 30 meters per pixel. For the better understanding, I just attached the normal view and satellite view. Here you can see the cars at different shots. One is too far with less details. Another one is near and detailed. With these we can say this is low and this is high resolution. In the right side, the features are more detailed. Just look at the trees. Now satellite view. Low detailing, very less. Next, medium. Somewhat we can try. Last is high, literally detailed. Here we can notice the rooftops, roads, vegetation pattern, even a water body. This comparison is just for an understanding. Actually, every resolution has its own and its unique kind of purpose and research. Now, example and application. So for the first higher spatial resolution, World View 3, 31 centimeter is the highest resolution. But earlier we say 1 to 4 meter per pixel is the highest. Do you remember? For your information, 100 centimeter combined to form 1 meter. Here the resolution is 31 centimeter. How? Because it's panchromatic image. Simply pan image. If you know pan image, please comment. This application is urban planning, infrastructure mapping, then precision agriculture. Next one is the medium spatial resolution. So we consider Landsat 8, so 30 meters. So it is applied in land cover classification, environmental monitoring. The last one is a low spatial resolution. So here we consider mode is a low on terra and aqua. It's 250 meters. For climate studies, large scale land cover mapping, we use this low spatial resolution. The next one is spectral resolution. So the ability of a sensor to distinguish between the wavelength of light defined by the number and width of the spectral bands. And these are particularly detected by the sensors alone. And we should identify the objects in the form of spectral signature. Next types, there are 2 types. One is hyperspectral, another one is multispectral. Hyperspectral means hundreds of narrow bands. Example Hyperion. Several wide bands. Example Sentinel, Landsat, etc. Here you can understand the concept the way better. Normally our eyes captured similar colors as shown in the apple and cherry, but in the view of camera lens, adjustment, hue, saturation played a vital role. So we can differentiate the colors, shades in normal view, and it changes our point of view with more specification in images. Now satellite view, and this MSS image with spectral bands, this color of image are called TCC, true color composite. Generally we use FCC, false color composite, for analysis. And this is the spectra of MSS. Then this is hyperspectral, stacked image, same image only. For your understanding, I show like this with multi bands. Spectral signature displayed here is the original signature of Hyperion. Just look at the continuity. In this types, if you want to know in detail, do comment. Next example and application, hyperspectral. So the Hyperion contains 220 bands. If we use 220 means no. After processing, bands can reduce depend upon our study. I remember I used 198 bands for my study. It is very helpful in mineral exploration, vegetation analysis, specifically identification of a unique species. Each and every species of the plant, trees can be identified, and water quality assessment too. Next, MSS Sentinel-2 with 13 bands. Even Landsat, Moody's are also coming in the row. Why do I mention Sentinel? Because compared to others, Sentinel has more bands. That means 13. One is temporal resolution, my favorite. Compared to others, easily you can remember this because temporal means time. The frequency at which a sensor can revisit the same location on the earth, often expressed in days. I already told you temporal means time. In normal view, I just show the time lapse to actually have it's working for the understanding. Satellite view. It is the real change happened on this particular place. Just observe the changes happened over years. Amazing, right? I didn't categorize any types, directly get into the example and application. Here its resolution is categorized under the revisiting time. For high resolution, its revisiting time is 5 days. For Sentinel-2, so it is mainly used for disaster monitoring, crop monitoring, deforestation tracking, etc. And for the moderate temporal resolution, Landsat 8. So it took time for 16 days, and seasonal vegetation studies, hydrological studies, etc. And for the low temporal resolution, Valve View 3, several days depending on the latitude and tasking. Infrequent change detection, long-term environmental monitoring we can do from this. The last one, radiometric resolution. I just start with a simple explanation. We all know radiometry, measuring light in any portion of electromagnetic spectrum, because basically sensor records few regions of EMR only. But in radiometric, especially in the grayscale, it records bit by bit. That is, the ability of a sensor to distinguish between slightly different in energy or intensity levels expressed in the bits. Example 8 bits, 12 bit. In screen you can see the 2 km and 1 km bit. So for the normal view, I took Eiffel Tower as an example. Left is 8-bit image and right side is a 16-bit image. You can see the detailings too. Compared to the left, right side image is brighter and features are visible. Clarity is there. Same bit and the same bit variation for the satellite image as well. You can see the variation and detailing in both images. Example and applications. High radiometric resolution is Landsat 8. It's 12-bit. Precision agriculture, environmental monitoring and mineral exploration, and even for urban planning. And for the moderate radiometric resolution, Spot 5, 10-bit, forestry management, disaster assessment, regional planning. And for the low radiometric resolution, older sensors like Landsat 1 to 5, 8-bit, basic mapping and large scale in environmental monitoring, climate monitoring, oceanography, and broad land use mapping. Please do subscribe. Hit the bell icon. Thank you. Bye bye.